The simple answer is the uneven heating of Earth's surfaces. What does that exactly mean? What it means is for some reason, some part of the Earth heats up faster than the other parts of the Earth. Now, this can happen globally or it can happen locally. Globally, it can be due to the tilt of the Earth and the shape of our planet. And that causes, of course, our equatorial regions, the tropics, to heat up faster than our polar regions, mainly because the tropic regions get direct sunlight, whereas our polar regions never do. And this can, of course, cause those two regions to heat up differently, which is going to cause different air pressures. We can actually have this also happen locally due to different types of Earth surfaces, like you see here. We have a blue line here representing water and a black line representing dry land. Or thirdly, it could happen due to topography, like this mountain over here. That also can cause wind. I'll try to explain that later in this Nearpod. But first, let's just try to show you the basics of what causes wind, whether it's globally or locally. What you have is two different areas heating up differently. One area is getting warmer than the other for one of the three reasons I just went over. The sun, through the process of radiation, warms the Earth. But again, some places warm up differently than each other. In terms of land and water, land heats up quickly and cools quickly. Water heats up slowly and cools slowly. That will be important later for land and sea breezes at the beach. But let's just act like we're talking about a sunny day at the beach. So again, land heats up quickly, water heats up slowly. Well, the air above these two different surfaces takes on the characteristics of the surface below it. And what that means is this. The air above the land is going to heat up faster through the process of conduction because it's going to be touching it. That's going to cause this air above the land here to rise up because it's going to get heated more and it's going to become less dense. The air particles are going to expand and it's going to rise. This is going to mean air particles are leaving this region right here. It's going to make an area of what we call low pressure. Over here, it's going to be cooler. The air particles are going to start to shrink down into a smaller area. This is going to make an area of what we call high pressure. Notice that high pressure symbols, when you see weather maps in the future, are always going to be blue H's and red L's for low pressures. And it's kind of actually showing you a little bit about the temperatures in those areas. Because this area is cooler, okay, the air particles are going to contract and make them more air particles for the volume of this area here. It's going to, aka, it's going to be denser. And it's going to be pulling air down. Air is literally being pulled down into this area, opposite of here where air is rising. And what that's going to form is two different air masses, a high pressure air mass and a low pressure air mass, where air is rising here and air is actually sinking into this area here. So what we have now is an imbalance in the amount of air in two different places. And nature always moves things towards balance. As we saw when we were talking about thermal energy, high temperatures or warmth always flows to cold. The same thing happens here. We have a lot of air particles over here, and they're going to move into an area where there's less air. And that motion is what we call the wind. It is air trying to balance itself in terms of density. The cold air is going to move into this area here. Now, as it moves into this area here and replaces it, it's then going to start to take on the characteristics of the land that's now over. and through conduction, it's going to start to warm up. This area that has risen away from its heat source, which was the surface conducting into it, it's going to start to cool. And because air is sinking here and contracting into this area, this air is now going to be pulled towards it. It's A, cooling, and then B, being pulled in the opposite direction of this air down here. And what you get is our old friend, a convection cell, which we saw during plate tectonic theory. And this is the wind. Along the surface, the wind will flow this way, trying to balance out the amount of air particles, making it even. But up here, the flow will be in the opposite directions. It'll actually move opposite of the wind along the surface because it's the top of the convection cell versus the lower part of the convection cell. They're going in opposite directions. So this basically is how wind occurs. It is a convection cell where air is trying to balance itself out due to, again, uneven heating. This area, because water doesn't warm up as fast, will be colder. In this area over here, which land does warm up faster, you're going to get two different pressures from that. And wind is basically nature trying to balance those two pressures. I hope this helps you understand wind. And if not, we can answer any further questions for you.